In this video, we're going to talk about the principle of mathematics induction. So let's say you have a set of numbers, say 1 plus 3 plus 5. Now the pattern of these numbers follow a pattern of 2n minus 1. So for whatever term of these numbers I want to find, I can plug the value into this equation and then I'll get that number. So this is a statement. So this statement, we can say, okay, this statement is equal to n squared at any point. So let's say I pick the third number here, okay? So this will be 2 times 3 minus 1, okay? So 2 times 3 is 6 minus 1, 5. So that's the third number on this set of sequence, okay? For the third number, we know that 1 plus 3 plus 5 is 9, okay? So for the other side of the equation, we can say 3 squared is also equal to 9. So for whatever number we pick, we can find the sum of that number and we can say, okay, this part of the equation gives us the answer to that sum. So principle of mathematics induction kind of give us like a way to prove that this statement is true. So normally what you call this statement is P of n. Okay, so this is a statement formulated in terms of natural numbers. Natural numbers are numbers that start from 1, 2, 3. So they are positive whole numbers. Okay, so we could say P of n, which is the statement we are looking at, is equal to n squared. Okay, so is this statement true? That's what principle of mathematics induction is trying to check. Principle of mathematics induction is consisted of 3 steps. So if you want to use principle of mathematics induction, you have to take 3 steps. So for step 1, you have to prove that n is equal to 1. Okay, so for the first step, you have to prove that n is equal to 1. And then for the second step, for step 2, you have to assume n is equal to k is true. And then for the third step, you have to show. So for the first step, you have to plug in the value of 1 and prove that it is true for the mathematical statements that you have. So you could just continue plugging values from 1 to 2 to 3 and you'll be getting the answers. But let's say if you get to like 100, your answer might not be correct. Okay, so for the next step, you have to assume any number, which is k in this case, and assume that it's true. And then you have to say, okay, does k plus 1 equals to true every time? If it is true, then your mathematical statement is true. Okay, so that's just a simple 3 steps to solving principle of mathematics induction. So let's quickly solve this example on the screen. Okay, so to solve these questions, we can easily take our 3 steps. So for step 1, for n is equal to 1, that's the first term. Okay, so we look at the first term here. The sum of the first term in itself is 1 here. So we know that P of 1 for the statement is 1. And then this is equal to, on the other side of the equation, we know that 1 squared is still 1. So 1 is equal to 1. So we know that P of 1 is true. We can still show that P of 2 is true. So let's try that. We know that P of 2 will be equal to, so let's say the second term is, this is the first term and then the second term. So 1 plus the second term is 4. Okay, so we know that 1 plus 3 is equal to, the second term is 2, so we have 2 squared here. So it's 2 squared. Okay, so 1 plus 3 is 4, and 2 squared is 4. So we've shown that P of 1 is true, but this one is just an attempt to show you that P of anything could be true, but it has limits. So you need to do your next step to make sure that it's correct for all natural numbers. So for step 2, we can assume that n is equal to k. So this is an assumption, and we assume that n is equal to k is true. Okay, so we can rewrite this statement here by saying 1 plus 3 plus 5, and then on up to 2k minus 1, and then this is equal to k squared. Okay, so that's all for step 2. Step 2 is simply just replacing n with k. So for step 3, we have to prove that n is equal to k plus 1 is true. Okay, so from here on out, we can say our statement becomes 1 plus 3 plus 5, and then on up to 2k minus 1. So the next term after 2k minus 1 is plus 2 open bracket k plus 1 minus 1. Okay, so the next term here is 2 open bracket k plus 1 minus 1. Okay, because we are looking for the next term after k. So here is now equal to open bracket k plus 1 squared. So we knew that all of here is equal to k squared. From this initial question, from this initial assumption, all of here is equal to k squared. So from there, this means that k squared plus open bracket 2k, I'm expanding the bracket directly, plus 2 minus 1 is equal to open bracket k plus 1 squared. So let's clean up space from here. From here we have k squared plus 2k plus 1, and then this is equal to open bracket k plus 1 squared. So from here on out, we have k squared plus 2k plus 1, and then this is equal to k plus 1 squared. So we can factorize this to be equal to this side. So if we factorize this, this would be equal to k plus 1 squared, and this is equal to k plus 1 squared. So that's to show that n is equal to k plus 1 is true. Okay, so thanks for watching this video. If you liked it, leave a thumbs up, share with your friends, and subscribe to the channel. Thanks for watching again.